All right, so 33. We have a ball being launched by a toy gun, and all the energy starts out in the form of potential energy of spring, right? This ball has been smushed down into the spring, then the trigger gets pulled, and the ball is going to go, it's going to launch up into the air, up to here, and at the highest point, we know velocity is 0. You learned that back in chapter 2. Now, they tell us here that the projectile, the ball, rises 20 meters above the starting point. So the book, I figured out what the book means here. The starting point is right there. So they're giving us h measured from where the ball leaves the spring. So h equals 20 meters. Okay? So from this data, and we know the mass of the ball, we know the mass of the ball is 20 grams, which is 0.02 kilograms. They tell us the spring has been smushed or compressed 0.12 meters. From this information, we're asked to find the spring constant of the spring. So we're going to use conservation of mechanical energy. In this problem, it's all conservative. The only two forces doing work are gravity and spring. In fact, they tell us right here, neglecting all resistive forces. Because what's the number one non-conservative force? Friction. If friction is present, then your mechanical energy initial and your mechanical energy final will not be equal. So this problem is purely conservative, meaning work non-conservative is 0. So mechanical energy initial and mechanical energy final will be the same. Okay? So let's make some room and solve this. Okay, so mechanical energy initial equals mechanical energy final, but there's 3 forms of mechanical energy. So this is going to be kinetic initial plus potential of gravity initial plus potential of spring initial equals all of them final. Kinetic final plus gravity final plus spring final. All right, where do we have to put the initial? The initial is going to be right here when the ball is smushed into the spring, right? The spring is loaded and the ball's just sitting there, okay? So then the trigger gets pulled, the ball gets launched. Up here is going to be our final, right? So we have initial and we have final. So let's go through the energies. When the ball is sitting down here on the spring, the loaded spring, do we have any kinetic? It's not moving yet. There's no kinetic energy. Do we have any potential of gravity? No. I would say no. Because why? The ball is where? On the 0 point. So I'd put the 0 point like right here. Make that your 0 point. Okay. Okay, does the ball have, so there's no potential of gravity. Does the ball have any spring energy? Yes, because the spring is loaded. Okay, so then the ball gets fired, the ball goes up, 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 up. Okay, at the highest point, is there any kinetic? Nope. Is there any potential of gravity up there? Yeah, because it's above the 0 point. Okay, so that's not 0. Okay, any spring energy up here? Nope. So what we're left with is the potential energy that was initially in the spring gets converted to potential energy of gravity. So what's the equation for potential energy in a spring? 1/2 kx squared. What is potential energy of gravity? mgh. So we're solving for k. So k will be 2 mgh over x squared. Okay? And we have all this, right? So it's going to be 2, the mass of the ball is 0.02 kilograms. Gravity is 9.8. H. Now look here, what did I say? 20 meters above the starting point. So you know what, guys? The 20 meters, I take this back. See, this confuses me. Above the starting point. So you know what? They mean from there. So scratch that out. The 20 meters is measured from where the ball starts. I would make that more clear on the quiz. You guys see how that's kind of confusing? So okay, so that's 20 meters. And then how far was the spring compressed? 0.12. So you punch that into your calculator, and we come out with a spring constant of 544. So K is equal to 544 newtons per meter. It's not, I mean, the only hard part, the only thing I don't like about this problem is they're not clear about where the 0 point is. You know, is the 0 point where the ball is smushed into the spring, or do they mean from where the ball comes off the spring? That's the only thing I don't like. Okay, part B. What's the speed of the projectile? What's the speed of the ball as it moves through the equilibrium position? So I'm going to revert this, if that's okay. So the equilibrium, where is the equilibrium position of the spring? The equilibrium position of the spring is where the spring is not smushed and not stretched, which is right here. We're looking for the velocity of the ball the moment it comes off the spring. Now there's two different ways you could do this. You could do this where you make, here's the first way you could do this. You could make this the initial, you know, when the ball is smushed into the spring, make that the initial, and then make this the final, right? And you could find the velocity. What's the other way you could do this? You could make this the initial, and then the ball goes up, 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 like this to that point up there, and then velocity is 0 up here, and you can make that the final. So both ways would work, right? So which way should we do it? You guys have a preference? Let's do this. Let's make the initial, when the ball is compressed against the spring, let's make that the initial. So the initial is when the gun is loaded. The final is when the ball comes off the spring, okay? So let's go through our energies. There's no non-conservative forces. So mechanical energy initial is going to be kinetic plus potential of spring equals kinetic final plus potential of gravity final plus potential of spring final. All right, so let's go through the energies. The initial is here when the ball is on the spring, and then the final is going to be when the ball comes off the spring. We're looking for the velocity when the ball comes off the spring. So do we start with kinetic energy when the ball is on the spring? No, the ball is just sitting there. No kinetic. Do we have potential of gravity? Because you know what? The 0 point, whenever you do potential of gravity, you got to set your 0 point. The 0 point is at the lowest point in the problem. That is the 0 point. In fact, let me draw that nicer. The 0 point is this red line right there. That's the lowest point in the problem. Okay, so there's no potential of gravity because why? It starts on the 0 point. Okay, do we start with spring energy? Yeah, the spring is loaded. All right, so then the trigger gets pulled, the ball gets launched. So at the moment the ball comes off the spring, do we have kinetic? Yeah. Do we have potential of gravity? We do. Why? It's only going to be a little bit, but why do we have potential of gravity? Because the ball went above the 0 point. It's going to be a tiny little bit of potential energy. And then do we have any spring energy? Nope. Why is there no spring energy? Because the spring has been released. All the energy came out of the spring. So what we're left with is this. The initial energy in the spring is going to get converted into two things: kinetic energy and potential of gravity. So now let's put in the equations. So potential of spring, what's the equation for that? 1/2 kx squared. Okay, kinetic energy is what? 1/2 mv squared. Potential of gravity, mgh. But look, what is this h here? The h is the what? The x. It's the same distance as the spring was compressed. So we'll just call that mgx. Okay? Now what I would do is multiply everything by 2 to get rid of the 1/2. So this is going to become kx squared equals mv squared plus 2mgx, and we're solving for v. So the rest of this is algebra, so I'm going to make some room here. So we're solving for v. Velocity, so I'm looking at this equation right here. Velocity is going to be square root of kx squared minus 2mgx over m. So then we plug in. So we now know k. K is 544. X is 0.12. Oops, I'm going to run out of room. You know what, guys? I'm going to leave units off here. Bad physics teacher. I'm going to get fired. But I'm out of room. Desperate times call for desperate measures. We're leaving units off. I'm going to go crazy. Be crazy, dude. 544. X is 0.12 minus 2. The mass is 0.02. Gravity is 9.8. Squeeze it in here. 0.12. Got it. Okay, and then mass is 0.02. You punch this all in, and it comes out to be about 19.8, I think. I think that's right. It might be wrong, but just check the algebra. I think that's right. It might be a little too big. Is that right? Okay.